Okay, so y equals e to the power of x. I know that approximately it looks like this. Okay. Also gonna include here x equals 0. Okay. And x times e to the power of x. So right there is 1. Okay. So e to the power of 0 is 1. So it's gonna still pass through there. Now the question is, if you get these values which are greater than all 1, so I'm talking about the y values, if you take those values, right, and then times by x, so let me draw the line here, y equals x, like that. Okay. So from 0 to 1, right, 0 to 1, these y values are actually smaller. Okay, they're smaller than they're smaller than 1. So if you multiply to these y values, you know, these values right there, it's going to actually start from here. Okay, so it's going to start from there, and beyond this point, okay, it's actually gonna be higher, like that. Okay, so this is, I'm doing this without a graphing device, right? Because I know that these values, if they're multiplied by something less than 1, it's gonna go below. So we're really talking about this area because x equals 0 is the y-axis. Okay, and they definitely intersect at 1 and 1. Okay, 1 and e. Okay, 1 and e. Okay, so we're going to integrate from 0 to 1. The graph that's on the top is e to the power of x. Subtract x e to the power of x. Okay. Okay, so let's separate that. 0 to 1, e to the power of x. Okay. Dx minus integration 0 to 1, x e to the power of x dx. So this one is simple. This is, if you do the antiderivative of e to the power of x, it's still e to the power of x. So you're going to be e to the power of 1 minus e to the power of 0. This one here, this is actually a little bit more tricky integral. Okay, you actually have to use integration by parts. Okay, so in the Stewart's book, that's 7.1. Okay, and here's the technique. You let u, okay, u equal to one part of the factor. So I'm going to let it be x. You let dv be e to the power of x dx. So the reason for me doing this, right? Please refer to the lecture at 7.1 or integration by parts lecture from your class or anywhere you've seen that before. Okay, so I'm continue with my process. Du is equal to dx, v is equal to e to the power of x. So I can treat that as the following. It's x times e to the power of x, okay, minus integration of e to the power of x. Okay, all 0 to 1. Okay, 0 to 1. Maybe I should use a different bracket here, a wiggly bracket. Okay, so this is e minus 1. Here, if you plug in 1, you're going to get e minus 0. Okay. And here you're going to get minus e to the power of 1 minus e to the power of 0. A lot of brackets here. Carefully, let's open the brackets up. This is just e. The minus e is going to be plus 1. Okay. Gone. So you have e minus 1, so it's e minus 2. Okay, that's about 2.7 minus 2.